Hello everyone, my name is Viraj and today we'll be looking at the 10th problem from the CP-31 sheet by TLE Eliminators under the 1000 rated questions. Let's go. So I'll move on to my sheet over here, ticked off 1000 rated, and we'll go on to the 10th problem, traffic light. Okay, let's read this. You find yourself on an unusual crossroad with a weird traffic light. The traffic light has three possibilities, very common sense: red, yellow and green. Red for R, yellow for Y and green for G. It is known that the traffic light repeats its colors every n seconds, and at the ith second the color is SI and on. Okay. That way, the order of colors is described by the string. For example, if S equals to R, G, G, R, Y, then the traffic light works as red, green, red, yellow, then again red, green, red, yellow, and so on. More formally, if you are given a string S1 to Sn of length n, and every first second the color is S1, so on, second is S2, and then at the nth it says Sn, and then on the n plus 1th second it is S1 and so on. You need to cross the road, and that can be only done when the color is green. Okay. You know which color is on the traffic light at the moment, but you don't know the current moment of time. You need to find the minimum amount of time in which you are guaranteed to cross the road. You can assume you can cross the road immediately. Okay, and then they have given you a neat example over here. Let's generalize this problem quickly. Okay, very simple problem. You have been given a variable n, that is size of the string. You have been given a character C, that is the color of the traffic light, you can say, and then a string S, which denotes the color of traffic light at it changes from 1 to n seconds. So this is, let's say, S1, S2, S3, S4, so on till Sn, and every letter Si is actually belonging from R character or Y character or G character. R means red, Y means yellow, G means green. Very simple. Now what are they saying is, if there is an initial C color given to you, which means this is the current traffic light color that you know, you have to figure out how much guaranteed time can you take to cross the road. Now crossing the road is only possible when a green color light comes. So the idea would be that this color C is of course going to be visible somewhere in this traffic light, you can say, string that is given to us. So let's say that C is present over here. Let's say this is the color C. And then let's say the green color is present over here. So I would say that from this C color, if I would be traveling and moving on and on, I would have to wait 2 seconds before from this C color, I actually encounter a green. So I can say that standing at this C point, I would require 2 seconds overall to cross the road. Now, if you go back, they have actually said that you have to find the minimum amount of time in which it is guaranteed to cross the road. This is a very tricky statement. What can happen is, let's say this C value is over here. Now, there can be another C value, let's say over here. And there can be another green that comes after it, right? There can be multiple C values in the same string. So if you figure out what is from this C, the closest guy of G, which is how much minimum time do you require to cross the road, then this is this G guy from this C. But from this C, this is this G guy. Their differences might be different, right? You can say that the time you would have to take to cross the road from this point to this G might be something different. From this C point to this G might be different. That means I need to figure out, if let's say this is D1, let's say this is D2, I need to figure out all such D1, D2, so on, all such differences that might be there, and I need to print the max of them. Why max of them? Because it's given in the problem that I need a guaranteed time. Guaranteed time means that what is the lowest possible time which you report in which wherever C you start from, you are bound to cross the road. So how do I get that? If I get the max of all these differences, then I know if I report that as my answer, any C value you pick up and any G next to G that you pick up, you will be able to cross the road within that bounded time reported as answer. All right. I hope this makes sense. There is again a small catch to this problem. Let's add on that quickly. Added to that part, they have also mentioned that the string is cyclic. What does that mean? Let's say that there was a C point somewhere over here, and then there was a G over here. Now, if you talk for this C, meaning when you start off with this moment of time and you start going right and right and right and right, if the string gets exhausted, you can imagine that you come back to the first location. This is the cyclic nature that means. So from this C point, I will go, end the string, come back to the first location, then again move, and then this G will be considered the guy for which I can say C if would you have started off from, then this is the total, you can say, amount of time I would be requiring to actually cross the road. So to calculate that, I would do something like this. I would get the difference from here to here and from first to this G. These two differences that we have calculated, these two blue lines then can combine together and they can together represent that, okay, this C took this much time to cross the road. Okay, now cyclic in this manner comes in a very good picture because you can imagine that, let's say after Sn you're talking about the S of n plus 1th letter. If that letter is actually back to S1, then I can just copy paste the string S1, S2, S3, S4, so on again and again like this. So from this C, you can say that this G guy over here, which was actually on S2, now comes at this location. So just an ease of diagrammatic format, I don't need to calculate this difference and then this difference. No, I can from this C directly say that, okay, going from like this to this G is directly this one segment that I need. I hope this makes sense. Let's actually take a nice example so that this looks very, very clear. Let's go back and see example number 4. Okay, let's see. So you have been told that the string size is 5. The color that you start off with is Y, that is yellow. And then the traffic lights are given like this. Y, R, R, G, Y. Then again, Y, R, R, G, Y. Then again, Y, R, R, G, Y. Something like this, you can say. Now, if I talk about just the Y that is placed over here and the Y that is placed over here, I need to figure out what is the next G that comes to Y so that I get an idea that when do I actually cross the road. So I'll say from this Y, the next G is at this location. And from this Y, the next G is actually at this location. And then this is all. These are only the two Ys that I wanted to cover. Remember, don't get confused that you're trying to cover these Ys also, because if you start doing that, that basically means the repeated answer is coming into picture, because the same two Ys are placed at this location, same two Ys are placed at this location, this location, this location. So if you just figure out the answer, by the way, for this much part, then you are good to go. That is just a single S string. Okay, so let's rub this back. I will figure out the answer for these two Ys. Let's see quickly. From this Y to this G, how much am I talking about a shift of time? I am saying that this is 1, 2, and 3. So I'll note this down, 3, comma. Let's talk about this Y. From this Y, if I need to go to this G, how much time? 1, 2, 3, and 4. Let's note them, 4. And let's figure out the max of this. This turns out to be 4. And let's go back. Is the answer 4? Yes, the answer is 4. Now, physically, you should understand what does this 4 mean. This 4 means that this is the guaranteed time in seconds in which if you start with any Y in your current traffic light system, you will actually end up crossing the road. And that is true. If you, let's say, start with this Y, you end up crossing the road in 3 seconds. 3 is less than equal to 4, the answer that you reported. If you start with this Y, you again end up crossing the road in 4 seconds, which is 4 less than equal to 4. So 4 is a guaranteed time. It's the time that is, of course, making sure that any other time is less than equal to this. So you will end up crossing the road. You will be able to get to the other side. Let's quickly take one more example, I think, and I think it's going to be much more easier. Let's take the last example. Great. I have quickly drawn this for you. Let's see. So let's identify first the Ys that I want. This Y, this Y, this Y, and this Y. Okay. This was actually the string. Then I repeated it once more, and this will continue to infinity. So you can understand that, of course. Now I'll say, okay, let's figure out the answer for this Y. What is the closest G to it? Move like this. So I'll mark this off with red, for example. You move from here 1, 2, 3, and you land at a G. So I can say this is 3. Let's note this down. This is 3, comma. From this Y, 1, 2, only 2. Okay. From this Y, only 1. Okay, 1. Then from this Y, 1, 2, 3, 4. 4. Let's note this down. What is the max in this? max turns out to be 4 seconds. Let's go back. Is the answer 4? Yes, the answer is 4. Great. So I hope the question has become pretty clear. You are able to imagine the whole idea. All right. And it's a very simple problem. You can again pause the video, just see the cyclic thing for once. The cyclic thing might be a newer part or a trickier part. Just pause the video, figure out the other 4 cases I think we have not discussed, other 4 cases, and you will actually be able to come up with an answer and an explanation maybe on your own. All right, great. So we have understood the problem, we have understood the test cases. Let's move on. Let us first understand what is the time complexity that is expected in this problem. So we have time limit per test as 1 second. That is roughly like 10 raised to 8 order you can talk about. And then every test has test cases, that is 10 power 4. Although it has been given that the sum of n over all test cases doesn't exceed 2 into 10 raised to 5 order, which means I don't need to worry about these test cases. I can directly compare n over here. So I can say that if I have been given one test that allows 10 raised to 8 operations, and now n is given roughly in 2 into 10 raised to 5 order. Okay, so what sort of complexity can I actually make? Is O of n possible? Very obvious, it's possible. A little larger, n log n possible? Yes. A little larger, n square root n also, it's possible. But if you go a little larger, probably like something like n square, this is not possible. Come down, O of n to constant time, everything is possible. So all these complexities are getting promoted, and this is something I don't want. I don't want n square or above orders. And this is my expected time complexity. Very helpful, because now I have a rough idea that I want solution that runs in linear time or like linear into log sort of a time, nothing in square order. And this is very important because if you look at the problem, it talks about repeating the string, right? So you might also understand from here only that there is a hint. We don't actually want some solution which repeats the string many times. Rather, something clever might actually be the answer. All right, great. I think this part is clear. Let's move on to our final solution. So first of all, when you understood the cases also, I think one thing became very, very clear, that what is our target? Let's note this down. Our target is to somehow, for every color C, find the rightmost, or you can say just right G position. If we are able to, from let's say a C color, there is right G that falls over here, another C color, for example, another G that falls over here. For example, let's say there is some C color which is cyclic. So maybe some portion till here, then goes back, and then some portion till here, another G that falls over here. If you are able to figure out for every C value, the rightmost or the just right G that follows, the G position rather that follows, then we will know that what is the difference of time that will come from traveling from this C to this G, from this C to this G, from this C to like this, and then like this G. We will of course get those values. And then the answer was very simple. We discussed that if we take the max of that, that is guaranteed to give us the exact bounded time under which I know that every C will work out. Any C you start off, you will be able to cross the road. So that means getting those differences are the main key in this problem. If I get these differences, taking a max is not going to be a big issue. I hope that is clear. So this now tells us that the whole problem is just about implementation. How smartly or how well are you able to fetch this C value for you? And I think that is the main idea. All right. So now if you talk about a very brute solution, you run a for loop. This for loop, for example, traverses to every I index. Inside this, if you figure out that S of I, for example, is whatever this color that you were talking about is the color C, then you might actually want to run another for loop right from this position. So whatever this I position is, you run something like J equals to I plus 1. Just after that, you keep on moving, and somehow considering the cyclic movement also, you are able to figure out that what is that next G that follows. Maybe there is some J index which comes out to be G, and you will say, okay, this J index is G, fine. J minus I sort of creates a difference that, okay, from this I index to this J index, this is the travel time, and I can then max this out. This is like a very general brute idea that comes into picture. In this rating, I think this should be very, very clear and intuitive. But the main problem with this is sort of an O(n) order, and this is sort of an O(n) order. So this creates an n square solution that is not promoted. We will get actually a TLE in this. Great. So I need something like this, but optimized. Let's analyze. Right now, our brute solution said n into n. The outer n was to go to every ith index. And then the inner n was to figure out that for every ith, which is that jth index. For every ith, which is that next jth index, which has a G kept at that. So I cannot optimize the outer because I would have to travel to every index in order to get which indexes actually have this C color. So I know I cannot optimize this part, but this part is optimizable, where what I'll do is I'll actually twist my tail a little bit. Right now, we are traveling from left to right. When we come at a color, and if that turns out to be C, we figure out what's the next guy that is G. Let's do a different thing. Imagine that you would have been given a test case. Let's take one more test case. For example, let's talk about the fourth test case only. Okay, so we had something like a 5y, and then we were repeating. So this was y r r g y. So this was y r r g y, and then this was y r r g y, and then y r r g y, and this was getting repeated. Now I only want to consider one portion of the string because other answers are always going to be same. Okay, let's see. If I talk about this y over here, the g value that is on the right of this is actually this. So now you can understand that the boundary of exploration is not exactly up to one part of S, but rather the y values who belong after the last g in this S only will of course land up with a g value that is in the other segment because we have a cyclic manner. So maybe we can twist our idea, and rather than running our loop from this location, we can start running our loop from this location. Now, what am I going to do? Listen to this very carefully. When I'll run a loop from this location, as in I'll go from right to left. When I move on from right to left, I am going to note down whenever a g value comes with me. As in, I can have some sort of an index variable, and I'll say, okay, if this is marked up 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, I'll move on to the index 9. Is this a G? This is not a G. This is actually a Y. Now, right now, there is no index with me which has a G value. So I can maybe initialize something like -1. So I can keep a check. I can say, okay, right now when I landed at a Y quickly, I had no G after this Y for this purpose. So I'll say, okay, let's move on. Let's ignore this Y because I don't have any G to allot to that or compare to that. Okay, let's move. Oh, I land at a G. So what will I do? I'll upgrade this index and I'll make it this 8. So this index would actually denote the last G that I have now. Now the last G from the back is at the value or the position 8. Great, let's move on. Index 7, this is not Y, no worries. I don't need to bother about R only. Index 6, not a Y. Index 5, this is actually a Y. Now if this is a Y, then I know that to this Y, on the right, if there is some G that I have with me, I want to take that. So let's see, to the right, there is actually a G, and the last G that I saved over here was actually at the index 8. So I can say that 8 minus 5, that is the index I am right now in, actually creates a difference 3, which means that for this Y guy, this G actually satisfies. I hope this makes sense. Now I'll say, okay, this is 3 that was noted down. I'll move on. Let's go to this Y. Now G has not changed because you did not encounter any other G. So for this Y also, the rightmost G is still at the 8th location. So now I will have a difference that is 8 minus 4, which is equal to 4, which makes sense because for this Y guy, you actually wanted this G. Okay, I hope this makes sense. Now let's move on again. You actually land at a G now. Now this now is a G. So the last G that was at 8 has to be upgraded because after this location, any other Y that falls will have this guy, this G, not this other G as the closest rightmost guy or the just rightmost G. So I'll initialize, or rather you can say update the value from 8 to 3. Then I'll keep on moving. I go to this 2. This is an R, don't worry. A 1, this is an R. And then the 0th index, this is a Y again. So let's again figure out the difference. I know that this Y's closest G is saved with me, that is at the location 3. So I'll say 3 minus 0, that again turns out to be 3. So now the values that I would maxing out from would be 3, 4 and 3, which would actually give me 4. 4 is actually the max of these 3 values. All right. And didn't we agree that 4 was actually our answer? Yes, 4 was our answer. So now this whole idea that we have just told you is just an implementative trick, by the way. Okay, this is a standard sort of an algorithm where, because we were giving a cyclic sort of a question where string was getting repeated, we justified our answer technique by actually creating a string S And then rather than just exploring this string s part, let's create one more s to that and start off with you can say if this is a total length of n and this is a total length of n. So we'll start off with a window of 2 into n. In terms of index, you can say 2 into nx minus 1. Let's start off from this location and keep on noting every g. Because if the last g is saved with me, or the index where I just got a g is saved with me, every y next to it or every y on the left of it will have this g guy as the rightmost g indirectly. Hence, I said in the very start that let's reverse our idea. This is what I meant by that. Now, once you actually understand that idea very nicely, you might actually be able to answer this small question also, that at the very start they had this y guy whose answer I did not calculate, but that was fine because this y guy by cyclic manner is actually this y guy only, right? Can you see? YRR GY, then YR GY. So if I would have calculated the answer for this y guy, I would have required this g, but I did not have that much window. So I just ignored that guy and I considered for this y. Answer indirectly still came right to me because I was considering in a cyclic manner. Those y's would have been again covered after I would have actually crossed a window of n and reached at a window of 0 to n. Alright, so I hope that you are able to imagine this part. Let's actually take one more test case. I think we can take the first test case now. That's a different thing and see again. 5R, then R, G, G, and then you had RY. Let's repeat this once more. R, G, G, RY. Let's run a loop from here. You can say there is some index called as -1 right now and you're looking for R. So let's take this index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We are at the 9th index. This is a y. Let's ignore. No problem. This is an r. Now I need to ignore this r because I don't have a g as of now. Index is -1. Let's go to this g. Oh, update 7. Let's go to this g. Again update 6. Let's go to this r. Now what's the last g saved? 6. Where am I right now? 5. So 6 minus 5 is 1. Alright, which means indirectly that this r guy would have preferred just rightmost g, that is at the location 6. I hope this logic makes sense. Great, let's move on. You move on to this location. This is a y, ignore. This r, cannot ignore. Now, this is at the location 3. The last g that I saved at is at the location 6. And which is, of course, by making sense diagram also, this r would actually move on to this g in order to cross the road. So I'll say 6 minus 3 is 3 as a difference. Great. Now let's go back again. We will say, okay, let's start with the next index. So what is the next index? I have the index 2. I'll move on to that. This is again a g. Let's update. This goes to 2. This is 1. Let's update. This goes to 1. Let's go to 0. This is an r. So was the last index saved? 1. What is the current index now? 0. So 1 minus 0 is equals to 1 is also now a difference. And now everything gets rubbed out. And what are the numbers you are wanting to max out from? 1, 3, and 1. Let's take the max of all this. This turns out to be 3. That means boundary or the highest time you report is 3 seconds, under which, you know, now any r you start with, you will actually end up crossing the road. And that is correct. Let's go back. 3 was voila the answer. Okay, had you started with this r, 1 second. Had you started with this r, 3 seconds. So that makes sense. You actually figure out that 3 is the answer. All right. Now there is one more optimization to this. If you don't want a solution that is neatly in this sort of a manner, you could actually have done similar to this brute idea only, but rather than this inner Owen logic, you can actually implement something known as binary search. And maybe from that binary search order, you could have figured out the next G. I'll drop or leave this out for you to comment in the video and let me know what ideas can you think you can implement for an idea where I would have done an O of n solution outer and inside something better than this, hint binary search. Okay, I hope this part is clear. Let's actually move on. And finally, I think when we have discussed the whole part of the question, let's once more discuss one very important thing, that is what sort of a final code piece pseudo structure will I look at? I'll say that I'll take the input of n, I'll take the input of s, then s can be again concatenated with s. So I'll say s plus equal to s so that it creates basically one larger string which has s and then s, because that is what I roughly want. And then because size is also doubled, so I can say n multiplied equal to 2, so n also doubles. And now I would try to run some sort of a for loop from the back end side. So something like n minus 1, the last index, 2 I'll go to 0. When I say s of I is equal to g, then my index value will get updated. Index value will become equal to I. Okay. And if s of I turns out to be my color, then I will max out I will max out whatever is my answer. Let's say answer equals to max of answer, comma, whatever is this difference that is there. That is the last location index of G and minus my current location I. And this is my pseudo idea. Great. I think we understood the problem. What is the time complexity for this now? This is roughly like O of writing 2 into n because the now string has size gone to 2 into n. But you can ignore this 2 factor also because this is just a constant 1. So we can roughly report this as O of n. And this is very, very nice because as we discussed in expected time complexity discussion, this is definitely a solution I would have loved to create. All right, great. I hope the problem and the solution is clear. Let's move on to a code part. Just how I explained the pseudo structure, same thing I'm going to do in the code. Let's take the input of t. Then I have the input of n with me, then the color, then the string s. Then I will first concat s onto itself, so s plus equal to s, n multiplied equal to 2. Then the last index is -1. Max seconds are int min, and then I can run the loop from behind. If this becomes g, then last green index becomes I. If this is color, then I calculate the difference, that is the last green index minus I, g minus whatever that color is, and then max out with my answer, that is max seconds I want, guaranteed seconds I want, whatever you call that. When I end this for loop, I know max seconds has that best largest difference that is guaranteed in which I cross the road. Let's print this and that gives me my answer. All right. Now what is the time complexity? You will have some time order over here to take the input of s. Then this is also going to have an n order because you want to concat onto itself. Then this is pretty much constant. Then this is roughly like a loop of, as I explained, 2 into n, but you can write this as n order only. And then inside this, everything is pretty much constant. So if I figure out what's the time complexity, as I mentioned, O of n, you can say, which means this is O of 2 into 10 raised to 5 order. What about space? Space complexity is O of like 2 into n because now the string size is doubled, but again, you can ignore that too. So you can report this as O of n only. All right. So a fun problem. Takeaway is again this cyclic concept, right? There are a lot of problems which actually incorporate this manner. This is sort of a technique that is also popular in modular arithmetic. So you can try to pause the video and give it 2 minutes thought that when did this cyclic thing come into picture? How could I have tackled this in other way also? And then you can come up with your own implementation. It's not necessary that this is the same implementation. The idea, the crude idea should remain same. You just have to figure out the best way to get those largest differences, or rather the differences and the large out of them. And I think if you're able to do that, you will be able to solve this problem. All right, so that is all that is there in this video. Thank you for watching.